Interstellar objects like Oumuamua and Borisov were constrained by the limited instruments available at the time. Observations provided basic clues about their trajectories and surface compositions, but their true physical character remained ambiguous. With 3i Atlas, Webb's infrared capabilities have peeled away layers of mystery. The telescope's position beyond Earth's atmosphere means no atmospheric distortion. Its instruments can capture faint glimmers and subtle contrasts that ground-based observatories could never manage. The result is an image where Atlas is not a dim streak against a starfield, but a resolvable body with surface features, spectral details, and a visible coma of outgassing particles. One of the most striking revelations from Webb's image is the texture of 3i Atlas's surface. For years, theorists debated whether interstellar objects would resemble the icy comets of our solar system or take on the rocky profiles of asteroids. The captured image shows a surface that glimmers with reflective patches, suggesting volatile ices that are actively sublimating under solar influence. At the same time, darker scars and irregular shapes hint at impacts and fractures accumulated during its long journey through deep space. This duality, part comet, part asteroid, suggests Atlas might be a hybrid, carrying the building blocks of both rocky and icy origins. Such a body could only be born in the outer reaches of a distant star system, later ejected into interstellar space by gravitational encounters. The coma visible in the image, a faint but distinct halo of gas and dust surrounding the object, transforms Atlas from a mere rocky body into an active traveler. This halo is not as prominent as those surrounding large comets in our solar system. Yet, its presence speaks volumes. It means that even after crossing the void between stars, Atlas has preserved volatile compounds that are now being released under the warming touch of our Sun. This is crucial because it gives astronomers a pristine sample of interstellar material, unaltered by billions of years of solar radiation or planetary encounters. In a sense, Atlas is a time capsule from another star system holding unprocessed remnants of its original birthplace. Webb's instruments did not stop at imaging. Its spectrographs recorded the unique chemical signature of 3i Atlas, breaking the light reflected and emitted by the body into telltale bands. Early analysis already points to compounds both familiar and alien. Water ice seems abundant, but intermixed with exotic organic molecules rarely seen in solar system comets. These molecules could hold clues to how chemistry unfolds in environments vastly different from our own. Even more compelling is the possibility that such compounds are universal seeds of prebiotic chemistry, capable of seeding life when delivered to hospitable worlds. If Atlas carries such molecules, it strengthens the case that interstellar bodies are messengers of cosmic chemistry, scattering the ingredients of life across the galaxy. The sheer size of Atlas, as revealed by Webb's imaging, adds another layer of fascination. Unlike Oumuamua, which was a slender, elongated fragment only a few hundred meters long, or Boris, a relatively small comet-like body, Atlas measures several kilometers across. This makes it more akin to a full-fledged comet nucleus than a fragment. The scale suggests it survived a violent ejection from its parent system intact, a process that must have involved dramatic gravitational interactions with giant planets or passing stars. Seeing such a large object travel the gulf between stars underscores how dynamic planetary systems can be. If one large object can escape, countless others likely do as well, turning interstellar space into a quiet highway of wandering debris. The orbit traced for 3i Atlas confirms its interstellar origin beyond doubt. Webb's precise measurements of its trajectory show a hyperbolic path curving through our solar system only once before departing forever. Unlike comets bound to the Sun's gravity, Atlas is not returning. It is simply passing by, and Webb's image has frozen that passage in unprecedented detail. Knowing this adds a sense of poignancy to the discovery. This is a fleeting visitor we will never see again. Yet, it also emphasizes the importance of the Webb telescope in capturing such ephemeral moments. Without its capabilities, Atlas might have slipped by with only minimal observation, just another blurred entry in astronomical catalogues. Instead, it now stands as a case study in the birth, evolution, and survival of interstellar wanderers. Astronomers are already drawing comparisons between Atlas and the interstellar objects that came before it. Where Oumuamua's strange elongated shape sparked theories of artificial origin, Atlas appears more conventional, though still exotic in detail. Where Borisov behaved like a typical comet, Atlas presents a hybrid personality. These contrasts are invaluable because they highlight the diversity of objects flung from other star systems. No two interstellar visitors may ever be the same, reflecting the infinite variety of planetary system architectures across the galaxy. Webb's image proves that each arrival is a unique chance to peer into another world's history. Beyond astronomy, the implications of Webb's image ripple outward into other scientific fields. Planetary formation theories must now account for the fact that entire kilometer-scale objects can be expelled and travel interstellar distances intact. Astrobiology gains new data on how life's chemical precursors might be disseminated across vast expanses. Cosmochemistry, the study of the elements and compounds that shape worlds, gains a rare laboratory sample preserved from beyond our solar cradle. Even philosophy finds resonance here as humanity contemplates the reality that matter from unknown stars is brushing past us, tangible and observable in real time. The visual impact of Webb's image should not be understated either. For the public, the photograph of 3I Atlas is an invitation into the profound. Unlike theoretical models or blurry images, this is a real sharp portrait of an interstellar traveler glowing faintly against a tapestry of stars. It makes the vastness of the galaxy suddenly intimate. Somewhere out there, a planetary system gave birth to this object. Somewhere, forces tore it away, sending it on a trajectory that happened to intersect our small solar neighborhood. To look at the image is to see a story etched in rock and ice, a journey that spans millions of years and uncountable distances. Webb's achievement also energizes the conversation about how humanity might interact with such objects in the future. Today, we observe them from afar, content with the light they reflect.